Good morning, my dear students. I'm Sridhar Reddy, physics lecturer. So in today's class in the physics chapter kinematics, we are going to discuss the topic rest, motion, distance covered, displacement, average speed, and average velocity. That one. These are the things which we are going to discuss in this today's topic. Okay, let me take you to the screen. Yeah, first we'll start with the topic, the rest. This one, how we define emotion, a body to be at rest. If a body doesn't changes its position with respect to reference frame, reference point as right timing, with respect to reference point or frame with the time, then it is said to be at rest. So usually what is the reference plane will take it? Let me take a wall, or not visible. Yeah, let me take this a wall. A person standing on the ground. So suppose like is at a distance of is here. So at t equal to 0 seconds is at a distance of say like a 5 meter from the wall. Then even after certain time, even after some time, say like after 30 seconds, even is at a distance of 5 meters. So what is this? This is a wall. Wall is a reference point. Wall, or I'll call it as a reference point. So then the body is said to be at rest. So if a body doesn't change its position with respect to reference point or frame with the time, then it is said to be at rest here. So like this will happen, we can define the idea of the rest. Okay, similarly, we'll take the next step, the motion. A body, if a body, will write it. If a body changes its position with respect to a reference frame or point, doesn't changes, here changes here. With respect to point with the time, then it is said to be in motion. Okay, let me take the same set of diagram. Look at now, is at a distance of how much? Let it be say 15 meters. 30 seconds. Did he change his position? Yes, in fact, the person has changed its position. Wall or reference point or origin, any of the things we define, then it's said to be in motion. If a body changes its position with respect to a reference frame or a point with time, then it is said to be in motion. What is a body? The person is a body here. Here, person is a body. Rather than saying person, no, we'll make it more generalized, like a body or a particle. There'll be more well-defined technical terms what usually we'll be using. So like this, we define the two quantities like a rest and the motion. Okay, next we'll take the other one, distance covered. The length of actual path traversed or covered by a body. This is called a distance covered. So moreover, it is a scalar quantity. It can possess, it can possesses infinite values between two fixed points or between 2 points, we'll write it. I'll give diagrams all, I'll explain. It always increases with the time. Okay, let's have one. Okay, these are the two fixed points or the 2 points I'm taking, A and B. What are the various paths? One path is what you can see AB. The other is this path. The other path. Okay, there's a path 1, path 2, path 3, and there's a path 4. So what is the total distance? Okay, this is the, so you can move in any path, that one. He will, person what happened first, he will also like, I'll take a vehicle. Okay, then let me consider the vehicle. Vehicle is moving from A to O. Then O to B. So this will be 3 meter. There's a 4 meter. So what is the distance covered? Distance covered will be S is equal to SAO plus SOB. So this is 3 plus 4, 7 meter is the distance covered. So you, I think, see, things are very simple. You are at T equals 0, you are here, and you are going to walk 3 meter. Then you'll walk another 4 meter. Then what is the total distance covered by you? Will be 7 meter. I think this is a very general. So don't remember all these things. Just you stand in your home, somewhere at a corner area, somewhere at a point. You walk towards east, then you walk towards north. That's all. So what is the total distance covered by you? Will be 7 meter. So instead of vehicle, no. So let you be that one. So I think if the moment if I say vehicle or body, you'll get confused. Let me bring a person, yourself. So now the person, what happened? Now you started at A and you ended at B. You can also move like this, no? And if you move like this, and you can move like this, so like that, between 2 points, what happened? You can choose any path. And for different path, the distance could be different here. It always increases with the time, the distance code. You see that one, as you move, you are here at T equals 0. With the time, what will happen now? The distance code by you will be increasing, no? So therefore, the last point is very important. It can possess infinite values. So you can move from A to B in any path. Then, so you are going to have the infinite values here, and it will be always positive. It always increases time. It will be always positive, distance covered. Okay, fine. So there's a one example is what I'm giving that one. So what are these? These are the different path 4, path 3, path 2. Shall we add one more quantity? Its magnitude will be different for different paths between 2 points. Okay, now what is the distance covered for this is like a path AOB, shall I write? Similarly, for the path SAB, it will be directly equal to distance AB, and how much is equal to? We know it will be 5 meters. Hypotenuse of a triangle, how much it should be equal to? The 5 meter. Or this very difficult to measure. So different path, it will be different values. So definitely I can say that path 1 not equal to path 2, not equal to path 3, path 4. The magnitude will be different for different path between 2 fixed points. Like this, we define a quantity called like a distance covered. Okay, next we'll take the displacement. Let me highlight them. Now the next quantity, the displacement. Okay, this one will define it as like shortest length measured between initial and final fixed points. Okay, the same set of diagram. What earlier we had, no, the same example will take it. So it'll be easy for us to compare things. There's a one path. Next, this will be the other path. This will be other path. This will be other path. Okay, there's an initial point. There's a final point. Initial point, and let this be final point. Okay, path 1. I'll indicate the path by the arrows. Okay, path 1, 2, 3, or we'll give name 3, and let me get 2, and this is 1. Shortest length measure between initial and final fixed points here. So among this, what is the shortest? I think this length, red color line, is what the shortest length, no? Able to notice, this is very important. So this is what the shortest. I'll just make it a little bit thick so that will be easy for you. So that red color line is what? The shortest one, no? Okay, this is shortest. I'll pick up some other color. Now you see like it. So now you do one thing. You start at A. In your home only. Let me not call particle or body. So you are here. You are going to walk like this. How much you are going to walk? You are going to walk a distance of 3 meters. Then you'll walk another 4 meters. First, you'll walk along the east, then along the north, and finally reach the point B. Tell me, what is the total distance covered by you? 7 meters. What is the displacement? Shortest length measured between initial and final point. So there's the initial point, there's the final point. What is shortest length? The hypotenuse will become shortest length here. So this will become the displacement, and it's having some specific direction. So therefore it's a scalar quantity. Okay, let's get into first mathematics. So what is AB square is equal to from mathematics? Okay, this should be equal to 3 square plus 4 square. So AB equal to 5 meters. This is the magnitude of displacement. Okay, agreed. Huh? Like this, we define this as the magnitude of the displacement. So what about the direction? The direction is along AB bar. AB bar should be equal to 5 meter along this unit vector. AB cap is what? Unit vector, which will be directed along the vector AB. Okay, like first we'll summarize points here. It is a vector quantity. Second one, it has unique value. See, I can move along path one. I can move along the hypotenuse. I'll move along this zigzag path, the curved path. But for all 4 paths, what will be my displacement? Magnitude of displacement will be same. Also, like a displacement will be same. So it has a unique value, irrespective of path here. It is independent of path. It has a unique value. It can be positive. It can be positive, negative, or 0. So it is independent of path. Just we'll put one of the condition. It is independent of path here. So for all the path, what happen? It will be same. It depends only on the shortest length measure between initial and final point. So therefore, we just put one condition that it is independent of path here. Next, what we can select for path 2. For path 2, distance covered is equal to magnitude of displacement. Okay, this one, and one more point will summarize here. What is that? Distance covered will be always greater than or equal to magnitude of displacement. There's another third condition. Let me put it here. So if you see this, so so yourself only. So you walk 3 meters, then 4 meters, then you reach point B. You may move along the hypotenuse. You may move along this blue color line. You may move this particular path. What about the distance covered by you? In all four different paths, it will be different. But for all the 4 paths, what will be the displacement? Will be same. So therefore, it is independent of path. I'll write it. For all this path, the displacement will be same. So therefore, it has a unique value. Able to understand? So I'm just explaining. So what do you mean by vector? It's having a magnitude. AB is a magnitude, and it's having some specific direction, no? Along northeast, we'll say. Along northeast. So it has a vector quantity. So what about, or what we can say, this theta, you write it. Or theta north of east, will write it. It's having some angle, theta north of east. If you want to express this unit vector, no, the direction you can also express in terms of that one. So east of north, if this is east, north of east, you have to call it. So like this, the displacement is what we define it here. So let me give a few more examples. Let me choose a. So this is the initial point A, B. So one, you are going to run like this. Another, your friend, what happened? Will take path like this here. So is a person 1, is a person 2. And then let this be coordinate axis. So there's the initial, there's the final point. Okay, now we can have things like this. Then what is the distance covered for the path one? Distance covered, let me take it here. Distance covered for path one. It should be equal to S1, should be equal to pi r. So what is it? How you'll move? You'll move along this semicircle. So what is the length of semicircle? Pi r. R is the radius of this path. Distance covered for path 2. It should be equal to how much? So you will move directly along AB, no? And it's equal to diameter. This should be equal to R plus R, 2R. Able to find, so this person will just walk along the diameter. So how much of distance he will walk? R plus R. So total length, how much of it will traverse? 2R. So look at the distance covered. It depends on path. No? What about displacement for both? The displacement for both as a vector quantity. Displacement for path 1. Similarly, the displacement for path 2. S1 bar should be equal to 2R high cap. S2 bar equal to 2R. You can pick up any path. So what are high cap? They're the unit vectors, which I'm going to define it. X-axis, y-axis. We'll define coordinate axis system like this. So look at now, things are very clear for you. So the displacement is independent of path here. It just depends upon the shortest distance between 2 points. How you move irrespective of that, the shortest length between 2 points is what should be taken displacement. So this is the magnitude. What about I cap? I cap is a direction. Distance called path length. How much distance you have moved. Okay, as I said, like it can be positive, negative, or zero also. Let me give examples related to that. So let me take 3 different situations. Very simple examples I'm taking. It will be really going to help you a lot. Okay, let this be the reference or original, call it. Okay, T equals 0, you are here. You are going to walk. So this will be the initial, you can call it. And finally, you'll reach here. This is the first case. And how much of distance you have moved? Total selected 10 meters. Fine. Okay, next, what is another path? Okay, there's a path 1. So next person, next time what you are going to do, you are going to start from here. I'll show everything red color. At T equals 0 started, there's a person 2. And finally, he will be here. So at what distance, how much of distance is at a distance of say like a 7 meters. Okay, there's a final point for him. Anyway, like that, there's the initial for him. Another person, what you'll do is like, third person, he will start from here. Third person. And finally, he will get back to its starting point. Okay, this will be its final. The fourth person, he will start from here. And finally, he will reach here. Okay, let it be at a distance of, say, like 4 meters on the left side. I took this as the origin. Okay, let's see that in different cases. Let me adjust this one. I need some space to scribble there. Let me push it here, all these things here. For path 2. Yeah, let's come for this one. Okay, there's a very simple example I took it. First case, so what happened to the person? The person will start at t equals 0. He will start at t equals 0. So what is the displacement of this person? We'll discuss all the things. Okay, I'm going to define this as a unit vector. Coordinate axis will take this is the origin. Origin, I wrote it here, or we'll do one thing. We'll keep that initial position of person will be the origin. First person, what is the distance covered, will be 10 meters. Distance covered by S1, 10 meters. What about the displacement? Displacement of S1. I should write it as S1 bar equal to 10 I cap meter. It's a positive, no? And similarly, distance, only I have to change the values, no? Yeah. Okay, let's come for distance covered by the second person. I think we have to be a little bit careful here. So how much of distance he has walked here? 10 meter. There's a 10 meter. Then remaining how much it is? 3 meter, no? So what is the distance covered by the person? So we'll write A2, B2, and this is C2. So what is the distance covered by this person will be A2, B2 plus B2, C2. I think this is a very quite common example. You walk first 10 meters, then you are going to return back. Okay, the return back I'm showing like this. I think able to understand. So what is it? How much of distance it will take to turn? Okay, to show I'm showing this turn here. Actually, you will return back. You will walk another in the return journey will cover 3 meters. What is the distance called? First you'll walk 10 meters, then 3 meters. So this should be equal to how much? 10 plus 3, 13 meters. What about displacement? Displacement will be shortest length. So actually this is a path. Path is like this. What is the shortest length? Will be 7 I cap only. Okay, distance covered by the third person. Third person will be 0. Displacement also will be 0. Any reason for that? Oh, sorry, distance covered will be like I will write A3, B3, A3. So what is the distance we will move now? Finally, A3, B3 plus B3, A3. So 10 plus 10, 20 meter altogether we will move. What about the displacement? Displacement will be 0. Any reason for that? A3, B3, I cap plus B3, A3 minus I cap. And what is A3, B3? A3, B3 is equal to 10 meter. B3, A3 equal to 10 meters. So this will be 10 I cap will be 0. Okay, this is the for person 2. Symbols I had to change, no? I just copied, pasted it. Okay, no confusion. So what is the displacement for the third person? Net displacement is 0 because where he has started, again he has come there only, no? Initial, final. There's the initial. So he has walked 10 meter, then again 10 meter. Distance covered will be 20 meter, you see that one. What about displacement will be 0. So here you see the distance covered positive, displacement positive. Distance covered positive, displacement positive. Distance covered positive, displacement 0. Okay, let's come for this one. So what is the distance you will move now? You will move A4, B4, B4 and C4. First you will walk A4, B4, then B4, C4. A4, B4 is 10. This will be 10 plus 4. I will indicate it. Total how much it will be? 24 meter. What about displacement? Little bit we have to be careful. Where is the initial point? There's the initial point. Finally is here, no? So we'll measure displacement, shortest length between initial and final. Don't measure like this. Huh? The displacement is along because it will go, then you will retrace path. Then what is the displacement? Minus 4 meter I cap. So this will be 4 meter. Look at the displacement negative, no? So therefore displacement can be positive, can be negative, can be 0, but distance covered with the time should be, as long as the person is in motion, the distance covered must be positive and it should be greater than 0. But displacement it can be negative also during a motion. So shall we conclude here? During a motion, the distance covered must be positive, non-zero during a motion of body. Displacement can be positive, negative, or 0 also. Shall we make a rule like this? During motion of a body, distance covered must be positive and non-zero. During motion of a body, displacement can be positive, negative, or 0. It all depends upon the type of motion. I just brought very simple. See, I'm not using word particle. Yourself, you stand at point 1, you walk. You walk and return back to certain point. Second case. Next, where you started, you go there, you walk 10 meters, again, return back. Next, you walk, then return back and cross that initial point. Displacement will become negative. Very simple examples I'm giving, which you can practice in your home. This is the basic idea. Finish over, nothing big is there. If you can understand the small topics, you'll be in a far better position. Got it? Okay, we'll take the next the reference frame will define it. What do you mean by reference frame? Because very often this word will be frame of reference. A system of geometric axis in relation to which a measurement of size, position, or motion can be made. A good example, geometric axis. So this X, Y, Z, these are the axes. I'll call this as frame of reference. So the person is at a distance, say like a 5 meters from the reference frame. Okay, this will become now the reference frame for us. A very simple point, you can just pick up any corner of a room, that will become a reference point for you. I'll call that as a frame of reference. Frame of reference can be at rest, can be in motion. Usually we'll just pick up the frame which is at rest. It'll be very easy for us to analyze the motion of a body. Okay, this is this everything system will depend. Suppose that you are somewhere here in the space. Then how we define this is R bar. So you have Y coordinate, X coordinate. So how you define R bar? X I cap, Y j cap, Z k cap. This is called like a frame of reference. So this origin, what happened, we'll call this everything coordinate axis, everything together, all these 3 coordinate axes, and this origin, what happened, we'll call it as a reference frame. It'll be very easy, no, for me if I have a reference frame. So in a very simple term, so what you can call the origin, you need some reference point. So the origin is what I'll treat as a reference point. What is X? I say that the body is at a distance X from the origin. The body is also at a distance Y from the origin. The body is at a distance Z from the origin. Together, I'll define that as a position vector. Okay, this idea of the frame of reference. So initial, again, when we go for the next chapter, laws of motion, we'll discuss in detail a frame which is accelerating, inertial, non-inertial. So time being, reference frame means for you, it's just like some reference point, or you can say some origin. Better you stand in a room. Suppose if this day you are in your house, if there's a room, no, you are here. So then if you take this as the origin, it'll be very easy for you, no, to define your position. Am I right? It'll be very easy for you to define your position. You are at a distance X, you are at a distance Y, you are at a distance Z. So this will become a reference frame. So is it a room or that origin is reference frame? Your room itself is now a reference frame. So to define yourself, what happened, your position, what happened, you are taking your room as reference frame. There's the meaning of this frame of reference. Got it? Huh? Okay, this is about the initial, the idea of distance covered, displacement, this one. Okay, now we'll define the average speed. We'll define first. Huh? Okay, first we'll define the, what do you mean by one dimension? One dimensional motion. Motion of a body along an axis with or without, we'll write it, with or without change in direction of motion is said to be one-dimensional motion, or we'll keep it here. Motion of body along axis with or without change in direction of motion. It is said to be one-dimensional motion. Okay, time being, we'll just define. So body moving along a straight line. a good example. Or there's one straight track, is there straight road, is the car is moving along it. It's the best example of one-dimensional motion. So we can take like, if there's a vehicle, so shall I say that it is describing one-dimensional motion? Straight road. Okay. Okay, now we'll define the next quantity, average speed. No. So the what is the symbol for this? This will be average speed. The symbol, what we use, this one. So it is defined as average speed equal to distance covered by time taken. So again, the same set of example. There's a path. There are 2 points. Let A be the initial point and B be the final point. So this length is 3 meters. This is 4 meters. I will take 6 seconds to cover this. Then I will take this as 3 seconds. Well, let me take 4 seconds. This is a path 1, path 2, this is a path 3. A, B, C, L, let me write it. So what is the distance covered when you move from A to C? So there's the initial, there's the final. Different path, the average speed will be different for different path. Okay, let me define first for the path 1, path 1, path 2, path 3. For path 1, what is the distance? Average speed. So V average 1 will write it. Distance covered, AB plus BC. What about time taken? TAB plus TBC. AB is how much? 3 meter. This is 4 meter. TAB is 6. This is 4. So 7 by 10. 0.7 meter per second is what the average speed. Similarly, what about average speed for second path? For the second path, it will be, let me make it some other curve. Quarter circle. Yeah, no, come for this one. Second one. Now, what is the average speed for second path? Distance covered. What is the distance covered? AC. Whatever the time taken, we have to define. So what is the time taken by the person to move along that particular path here? Suppose if it takes same time, it will take 7 seconds to cover this path. Average speed, because actually the person open, first he will move along this path. Next, it will take same time to move along this path. Then what is it? TAC, I'll write it. So it should be equal to, what is AC? AC should be equal to 5. Hypotenuse of a triangle. This is 7. So 5 by 7 meter per second. What is the average speed for the third path? It's a quarter circle. It should be equal to, distance covered should be equal to 2 pi r by 4. Time taken. Let him take here also 7 seconds. It cannot be quarter circle, no? Some path length I'll give it. It cannot be quarter circle. Curved path, I'll write it. Okay, path length. So it will be 3, 4. It will be some 5. It should be more than 5, no? 6 meter, I'll write it. Again, 7 seconds, so 6 by 7. Look at now. So time taken is same. Time of traverse for all 3 paths is same, but the distance covered is different. That's why the average speed will be different here. So I'll put it, let time of traverse for all 3 paths be same. There's the condition I'm putting. So look at average speed. Average speed is what happened is different for the different path is telling. Let the time of traverse for all 3 paths be same, or the time interval or time of journey, or anything you can put it here. So I just assumed it to be same for all the path. Then definitely what will happen? The average, the distance code is different, the average speed will be different here. So what is the conclusion we can make it here now? The first conclusion is average speed cannot be negative. Average speed cannot be negative. Then average speed can have infinite values, between 2 fixed points. Average speed increases with the time. Okay, I agree this. So these are things, and what is average speed? Average speed is the scalar quantity. Average speed is a scalar quantity. It will not have any direction. Okay, agree this? No. So like this, we can define the difference. So suppose if you take this is R, and I'll give one more simple example. Some of you are asking, sir, how it is. Let me define this is R. These are. So 3 different paths. Another person will move in a circular path. This will become quarter circle. There's an initial point A, B, C. This is the final point. Let the time of journey be same, t equal to 0, I'll write it. After some time t, they will arrive here. So there's a path 1. I'm putting arrows. Path 2, there's a path 3. What the average speed for path 1 will be r plus r by t. What is the average speed for the path 2? Root 2r by t. What is the average speed for path 3? It should be equal to pi r by 4. Sorry, pi r by 2, path length by t. So pi r by 2t. Like this, we can define that the average speed for different path. See, if they will cover different path length is different. If the time of traverse is same, okay, we can compare. If the time of traverse are different, suppose say here it will take some time. You'll cover more path in a given interval of time. Here you'll cover less path. Then if it takes less time, the average speed of these two may be equal. It can happen. It's not that average speed must be different. Average speed, if the time intervals are different, then average speed can be equal. And definitely the path length are different. If the time of journey of the three paths are different, then average speeds may be equal. So what we can conclude here, okay, between two fixed points for different path, the average speed may or may not be equal. If the time interval between time interval for different path are different, then average speed must be different. If time interval are different for different path, average speed may be equal. I think, can we put a condition? So between two fixed points, the average speed will be different if the time interval for all the paths are same. Then average speeds may or may not be equal for different path if the time intervals are different. So like this also condition, we can put it here. Between two fixed points, the average speed will not be same for different paths if time interval of journey are same. Okay, there's a one condition. Okay, next again. So all these are theoretical questions, unless if you have example, it'll be possible. You are not supposed to remember, you are supposed to analyze it. No, between two fixed points, the average speed may or may not be same. May not be same for different path if time interval of journey are not same. A good example, if the time of journey for all three paths are same, then average speed must be different, may not be same, will not be same, that one. Then if the time interval for different paths are different, then it can happen, no? Because I can adjust the value, it's a 2 or is that I can adjust value T1, T2, T3, the values of T1, T2, T3, so adjust I can that the ratio of 2R by T1 can be equal to root 2R by T2 pi R2 by T3. It can happen. Okay, these are the some conceptual points I'm trying to analyze. Okay, this is about the average speed. Okay, now so average speed. So we'll define the average velocity. Next page will define average velocity. The symbol we use typically like this. Some to show that it's a vector quantity, no? We use that bar. Average velocity is defined as displacement by time taken. Let me, I need some vector idea. So initially the position is here, or we'll take this initial position. And let this be the final position. So we define position vector R1 bar, this R2 bar. T equals 0, it was here. After some time t, the particle is here. Then now you define the displacement final position minus initial position. So this will be V average is equal to delta R bar by delta t. Delta R bar final position vector minus initial position vector by time interval. Look at R2 bar minus R1 bar. So if you know some vector analysis, R2 bar minus R1 bar is needed. So this is R2 bar This R1 bar minus R1 bar will be like this. Minus R1 bar will be in this direction. Then if I shift it, minus R1 bar, this R2 bar. So how delta R bar, this will be the delta R bar. Okay, fine. So I'll bring now the vector. So what is telling, the displacement average velocity will be directed like this. This is the delta R bar. What about path? How will move? It will move some path, some random path, let it be. The person is initially here. He will walk like this. There's a path and he will reach here. What about the average velocity, the displacement by time taken? We define like this. Now look at, there is so many things we have to be carefully, we have to analyze. So now person, how is moving? So it's moving along red color arrow. No, this is a path. I'm saying path, you must understand. Or like the person will move along this green color line. How it will be directed? It is independent of the path, no? It will be always directed from initial to final point. Suppose a person moves like this, then also delta R bar will be like this. If person moves like this, then also delta R bar will be like this. So shall I say that the average velocity is independent of nature of motion and depends only on delta R bar? The first point, V average bar is independent of nature of motion and depends on displacement. Again, same thing, V average, displacement can be positive, average velocity, V average can be positive, negative, or zero for a motion. It will have unique value, V average will have unique value for a motion between 2 points. Next, another one more. Direction of average velocity depends on resultant displacement vector. Resultant displacement vector. How we define? Basically defined as ratio of displacement by time taken. Is defined as ratio of displacement by time taken. It's a vector quantity, no doubt. It will be different for different path, no doubt. Okay, let me give one example. Let me choose I'll come to the next page. Same, that semicircle one, we'll take it here. So it'll be easy for us to analyze. Now there's a path. 3 different paths will take it. So there's a semicircle. Yeah. Okay, we you are seeing 3 different paths. There's a quarter circle. There's a path 1. I'm indicating by arrows. There's a path 2. This is this one. There's this quarter circle. Okay, there's the initial point A, B. At t equals 0, it started. At time t, it will arrive there. So path 1, path 2, path 3. Okay, already we have discussed the distance covered. No, 3 different paths are there. So first of all, we'll come for the distance covered. Once again, I'll repeat it so it'll be easier. So what is the distance covered for the path? Distance covered for path 1. S1 should be equal to radius of this, let it be r. Oh, I'll write it. So it should be equal to r plus r by t. So 2r by t. Already we have discussed, once again, I'm repeating. And now similarly, displacement. Path 1. Let me define this as origin. Let me define this as origin. So what is the displacement vector will be? How you define displacement vector? AB bar, AOR bar plus OB bar by T. So this will be RI cap plus RJ cap by T. See, here is what the use of vectors will come. Displacement, no, only displacement, sorry. Fine. Now similarly, we'll go for the average speed and average velocity. So what is the average speed? Distance covered. I made corrections. Average speed for path 1. That should be equal to r plus s1 average speed symbol. V average should be equal to s1 by t. So 2r by t. Similarly, average velocity for path 1. Should be equal to AB bar by T. That's all. What is AB bar? Let me define AB bar. Agree, this it's a very, very important thing, which I'm going to conclude. Really very, the statement what I was putting everything, I'm just going to conclude using this example. Distance curve for path 1, displacement, average speed for path 1, average velocity. Similarly, we'll define for path 2. All the theoretical ideas I discussed now at a stretch, I'm going to cover it here now. Similarly, we'll go for path 2. What is the distance curve for path 2? What do you mean by path 2? This is a path 2. Getting this? So what is the distance covered? You are going to move along this path. It should be equal to root 2r. What about displacement for path 2? It'll be same. S2 bar. Displacement is a unique value, no? The way I put some sentences. No, similar average speed for path 2. It should be equal to S2, this one. So this will become root 2r. What about the average velocity for path 2? It will be same. Similar the last one. Able to understand? So just like the whole today, what all we discussed now, everything I'm concluding in just by this example for path 3. What is the path length of this will be pi r by 2. The displacement will be same. Path 3. Look at the path 3, that quarter circle, green color one. I'm asking you to look at here. So what is the length? How much of length I'll cover? Pi r by 2, no? Quarter circle. So what is the average speed? Average speed will be, yes, 3. I just want you to see this particular thing. Look at average velocity for all the 3 paths. It's same, no? See, this is what a student has to really learn here. They are not theoretical ideas. The ideas are not just mere theoretical ideas, the sentences. They do reflect a lot of concepts here. Always the physics, when you take examples, it'll be very easy. With examples only, it'll be very easy. So in books, you have everything statement. I just gave one example. Fine. So let me summarize here. So look at for path 1, what is the distance covered? R plus R, 2R. Then displacement, Ri cap plus Rj cap. Average speed, time, what is the time of traverse for all the path is same. That's what we assumed it. What is the assumption? Let time of traverse for all paths and this is very important. Based on this is what I'm just discussing this example. If the time of traverse for all the paths are same, then definitely what happened, the distance covered and the average speed will be different. Where the displacement vector must be same. Average velocity will be equal. Try to notice this. I just wanted to highlight here. Let me just highlight everything. So this is one. This is for path 1. Anybody can take examples like this and you can study it. You're supposed to, you should always take example. Physics is not about reading content. You should take example, then you have to analyze. So what all I just put statements. I'm justifying all those statements today, what all I wrote just by with this example. Fine. So you please do think on these examples. Really, they're going to help you a lot. Okay, I agree this. So in today's class, what all we studied about the rest motion. So what do you mean by rest? If the body doesn't change its state of position with the time, is said to be rest. If a body changes its position, its position with the time, it is said to be in motion. Then afterwards, distance covered. Then we discussed displacement, then average speed, then average velocity. Then we took several examples where we are able to work out the distance covered and displacement. In tomorrow's class, next class, we are going to discuss about the instantaneous speed or instantaneous velocity. Okay, thank you. Let me hand up the class. Okay, kids, there's a first class in the kinematics. So I introduced you to the different types of the quantities like the rest, motion, frame of reference, distance covered, displacement, average speed, average velocity. So what I suggest is, like I said, no room. Okay, I have a room here. So can you move from one point to another point? Okay, you can move from one point to another point. So when you move from one point to another point, then that will become distance covered, displacement. Please try to analyze, because they're the very first basic things. If you can understand these things, the rest of physics will be very easy for you, because our whole physics will be fighting about what, like the velocity. So you should have the basic idea of the velocity. I said room, no, room will be of like this. So you just walk from one point to another point using different path. Path means like this. So you can start from one corner, go there, then come to that corner, then go diagonal, then walk zigzag path, then work out. After watching this video, you should work out here. You should think, understand them. No need to memorize anything. What all I thought, no need, no necessity of memorizing anything. Only thing is you should think and analyze, understand, and come to the next class. Okay, today it was only about the theoretical ideas. So tomorrow we are going to discuss some concepts where with the help of that you can enter into numericals. So when you understand these things, so numericals will be very easy for you. This is a methodology of learning physics. Don't focus more on remembering, just mere remembering. They will not help you. Okay, thank you all of you. Thank you. So we'll meet in the next class again. Thank you all of you.